When you're evaluating an integral, the first thing you want to ask yourself is, can I solve it just using the basic rules of integration? If that doesn't work, you check, can I use the method of substitution to evaluate it? And if that fails, then our backup plan is integration by parts. So the integration by parts formula says that the integral of u dv is equal to u times v minus the integral of v du. And at first glance, you might think that this formula is actually very useless because you started with an integral, and after you apply it, you still have an integral. It's actually not useless, and the reason for that is you started off with some integral that you couldn't solve, and the hope is that you're turning it into an integral that you do know how to solve. So you made the problem easier. To do integration by parts effectively, you need to be able to choose the function u correctly. And there are different ways of thinking about that. One way, a rule of thumb which often works, is to use this list. So the way this list works is you look at your integral and you find the first function type that appears in your integral that's on this list. Then you set u equal to that. So like if there's a log function, always set u to be the log function. If there are no logs, check for inverse trig. If there are no inverse trig, check for algebraic, etc. Since the exponential is at the very bottom of this list, it's actually pretty rare that you choose u to be e to the x. Once you know u, that actually determines what dv is, because we're turning the integral into u times dv. So after you've chosen u, dv must just be everything else that was in the integral, including the dx. So here we're going to evaluate the integral of the quantity x minus 5 multiplied by e to the 2x. Note that you cannot solve this using just the method of substitution. Like something that might come to mind is if you use the method of substitution, you could let u equal 2x. But what will end up happening then is that this x will turn into a u divided by 2. And then you'll end up with a u times e to the u. And there's no way to compute that without using integration by parts. So the first thing that we need to do when we use the integration by parts again is to figure out u. We have this list. I don't see any log functions, no inverse trig functions. There is, however, an algebraic function. That is the x minus 5. So in this problem, I'm going to let u equal x minus 5. Once I know u, I know dv, because dv has to be everything else in the integral. In this problem, it must be e to the 2x times dx. Once you find u and dv, from that you need to find du and v, because they play a role in this formula as well. Du is found using the idea of differentials. More explicitly, you take the derivative of u and then multiply by dx. But here, the derivative of u is just 1, and 1 times dx is just dx. To find v, you need to integrate dv. So in this case, we're going to integrate e to the 2x. And remember, the integral of e to the kx is 1 over k times e to the kx. So the antiderivative in this case will be 1/2 e to the 2x. You could formally prove that using the method of substitution. Now we have every single piece that we need to actually apply the integration by parts formula. Now we're going to need to plug everything into the right-hand side. So u turned into x minus 5. V appears in two different places, and they both turned into 1/2 e to the 2x. And in this problem, du was the same as dx. After you've plugged everything in, you should look for ways of simplifying. this new integral that you've got. Here there's a constant factor of 1/2. Might as well factor that out. And so now we have our new integral, which is clearly simpler than the integral that we started with. In fact, we're a little bit lucky here because the integral that we're evaluating now is the same one that we evaluated to figure out the function v. So it's still going to be another factor of 1/2 e to the 2x. So let's substitute that. This evaluated to 1/2 e to the 2x. And as usual, I should look for ways of simplifying my expression. I see that there are two terms that have a common factor of 1/2 times e to the 2x. So I should factor out that. When I factor it out, I just look at what was multiplying that common factor. There was an x minus 5 multiplying it, and there was a minus 1/2 multiplying it. To finish simplifying, there are two numbers in these parentheses. They can combine. -5 minus 1/2 is -10/2 minus 1/2, so that's -11/2. This is actually the final answer for our integral that we started with. You could check your work. Just like anytime you do an indefinite integral, you could take the derivative of what you found, and you should get what we started with. That is the definition of an antiderivative. So I want to make one important comment because you're probably more used to using the method of substitution. And in the method of substitution, it would be very common to let u equal like 2x or whatever the exponent of e is. But the way that you choose u for integration by parts and for u sub are very different. In fact, 2x isn't even an option for u when you're doing integration by parts in this problem. Let me explain why. The reason is we're trying to turn this integral into the integral of u dv so that we can actually use this integration by parts formula. That means u needs to be an entire factor in our integrand. So it could either be e to the 2x, or it could be x minus 5, but it can't just be the 2x. If I just let u equal 2x, then instead of having a u in this formula, I would have an e to the u, which isn't what appears here. So these are actually the only two options for u when we're using integration by parts for this problem.